Hi there, we're going to make a GUI for our sampler in this tutorial. So we've, in the last video, created a sampler, audio sampler in SuperCollider. Pretty straightforward, pretty easy. And now we're going to look at processing, and we're going to try to make just a simple little GUI, some buttons that you can trigger sound samples from. And also we'll cover the concepts of arrays and for loops and learning to iterate through data in an array that can make things really handy. So it gives us sort of a very easy way to recursion, to reiterate things, or iteration really, multiple things. Anyways, so let's get started. What we'll do is we'll have our standard startup and with the OSC. So I'm just going to sort of magically go away and do that so I don't waste a lot of time. You can pause and get it set up yourself, and I've covered OSC several times, so let's do that. Here's our basic OSC ready setup. So what I like to do is, again, as I've done in the past, do one version. So we're just going to make one button that triggers a sample, and then we'll multiply it out and kind of redo our code while we do that. Then let's have a basic rectangle square for our button. We'll have no stroke, and we'll have a fill of, say, lime green, and then we'll create a rectangle. Let's put it at, say, 50 x 50 y 50, and let's make it about 50 wide and high, a square. So if we run that, we have a little button there. So the next thing we'd like to do is I want it to perform an action when I click. So basically I have my SuperCollider sampler that I made in the last tutorial video. It's running and ready to go, and it's looking for an OSC message to play a sample. And I'm going to do that in mouse pressed. So void mouse pressed. And then I'm going to, now the next thing I have to do is detect whether I'm touching the rectangle that I drew. So we're going to just look at our mouse Y and mouse X coordinates and put some limits on them. So there'll be 4 arguments. We're going to make an if statement with 4 conditions, and they all have to be satisfied, right? So basically we're going to look at the left side of our square, the right, the top, and the bottom, and make sure that the mouse is within those. So let's look at the left. If mouse X, so it's going to be greater than the left edge, and right now we have 50, but let's make these variables actually, because it'll be a little bit more instructive that way. Okay, so we'll have int mx, and that'll be 50, and then we'll have an int my, and that'll be 50, and then we'll have an int ms, which will be 50 as well, and we'll make them all squares, so the ms will be both for the width and the height. So let's put mx in there, my, ms, and ms. Okay, so then now we can think about this in terms of variables. So mouse X has to be greater than or equal to ms, right? mx, sorry, the left-hand side. But also, and it has to satisfy the fact that it has to be to the right of the right edge of the square. So that would be mouse X is less than or equal to my. Okay, and then let's do the top and the bottom. So the top, MLUSE, Y is greater than or equal to my. I'm sorry, this mouse X is wrong. Forgive me. The right-hand side of the mouse X is not mouse Y, of course, but it's mouse X plus the width, mouse size, right? And in order for that to count both, we have to put those in parentheses. Okay, and mouse Y has to be greater than or equal to mouse Y, and mouse Y has to be less than or equal to, again in parentheses, my plus ms, the size of the mouse, right? All right, and then that's our condition there. So it has to satisfy all these conditions for it to be part inside the mouse, inside the square, the mouse to be inside the square. Make a few lines so you can see. All right, and then what are we going to do? Well, there we'll send the OSC message to trigger the sample. So OSC message, msg1 equals new OSC message, and it's going to be as we made in SuperClutter yesterday or the other time in the other video, play buff. Is that right? Yeah. And then we're going to add something to the message. And we're going to add a sample number. So right now I'm just going to play sample 0. And that's the first in the folder. Anyways, if you watch that video, you'll understand. It's we've loaded a folder of samples into an array, and that will be the first item in that array, the first sample. And then we'll send the message. But we'll use our OSC machinery. That's send. And what we'll send is the message 1. And where we'll send it is the SuperClutter SC net address. Okay. So then if we run this, all right, so there you go. You have a button and it's playing your sample, or one of the samples. All right, so now that's our basic structure. It's pretty straightforward. Let's try to multiply it so we can play multiple samples. And again, we're going to use arrays in this one, as well as for loops to iterate through the arrays. Okay, so for each of these we need an array. So we're going to have an int array, and we're going to call them, oops, and we're going to call them, what do I call them? Let me just get some of my naming straight here. All right, we need the initial x. All right, okay, all right. Right, so we're going to make an int array, and we're going to make a bunch of them. We're going to have left, right, top, and bottom. And then we'll have an initial x and y, just so we have original border. So we'll have int init x. Well, let's just make ix. And it'll be equal, or I use ix a lot, so I'll use xi. And it's the initial x will be, say, 20, and then yi will be 20 as well. Okay, so we have an initial starting place. And we have integer array, left, right, top, bottom. And then we'll have int called sc equals, and of course we can have several of these, but in this case we'll just have one size of button. Okay, so there we go. We've set up an array for the left, top, right, and bottom, left, right, top, and bottom coordinates of each of our buttons. And let's set those up now in setup. So we'll declare them out there, and then we don't have a thing, so this will be int, forgive me. Right, that's right. We're just going to declare them up here, so there's no equals, and then we'll set them up down here in the setup. Okay, so let's start with the L. So we'll say, oh, and then we'll have a number of buttons. I forgot about that. So we're going to have an int and numbut, num buttons, and let's make, well, let's make 5 to start with. So let's set these up. So we're going to run a for loop on the number of buttons, and then initialize these arrays, and then fill them with an initial value or not. We'll see. So we're going to say L equals a new, this is initialization process, int array, and its size, how many slots it has, is going to be the number of buttons. And let's fill those initially, so we can do we'll run a for loop to fill it. So for int I equals 0, I is less than num but I plus plus. And now if you, as a shorthand, if you keep everything in for loops and if statements, keep everything on the same line, you don't need to put the curly brackets. So we'll keep it all on the same line because we're just make one statement. And the statement we're going to make is we're going to fill I. So we're going to say L I is going to be equal to, well, I guess initially just 0. We'll just make them all zeros. Okay, and so let's repeat that process for each one. Right. Well, let's not make it 0, but let's make it xi, the initial x. Okay. So for now, oh, sorry. No, we actually can not only initialize them and fill them. We're going to go ahead and actually assign them coordinates, right? So that's okay. So actually, let's scratch that. So what we can do is instead of just filling it with a initial dummy value, we can actually assign them the right proper coordinates if we want to create, for example, a horizontal row of buttons. Okay, so we do need another variable there. We have a number of buttons, but we also need a button gap. We'll put that after size. So we'll need int gap. We'll just call it gap. We'll just call it gap. And let's make the buttons maybe 10 pixels apart, something like that. Okay. So in fact, what we can do is we can run through this for loop and we can increase the x. The y is going to stay the same, but the x is increasing, right? So this is the one we actually have to change when we initialize it. So if the initial one will be xi, let's think through it. So the first one will be at xi, or at 20. The next one will be at 20 plus the length of one button plus the gap. Okay? And the next one will be 20 plus the length of one button plus a gap plus the length of another plus a gap. So the amount that we need to multiply by is the length of a button, or the width of a button, and the gap. Okay? So that's our multiplier. So we're going to do the initial x, and we're going to add the length of one button, which is sc, the size, and as well as the gap. And we're going to multiply that by I. Okay? And we can put that whole thing in parentheses too. I think that might be helpful, just for order of operations and to keep everything clear. It might not be necessary. But so we're going to take add the size and the gap, multiply it by I, and then add the initial x. So if you walk through it, 0 will be 0 times that, so xi will be the first x. 1 will be the size and the gap, so one gap, one button size, and one gap over. That's the second button, third button, etc. So it does work out. Okay, so that's populated. Now we're going to repeat this process, except for the other ones, we just really can just keep them static, because they'll all be the same size, and they'll all be in a horizontal row, so the top will be always the same. So left, right, we'll do right. And the right, or sorry, what we need is, yes, we do need the right. Okay, yes, we do need all these coordinates, and I'll explain to you why. So the right will be basically the left plus the size. Okay, so if we change r here, so we want to change r here because we're doing the right coordinate. Okay, and the right coordinate is just the left coordinate, so li, and we can use li at this point because it's everything goes in order, and li was populated here. Sorry, again, I'm not thinking today. All right, so it has nothing to do with the x, so we don't want li, but in fact, what we need our right coordinate. Oh no, we do. Okay, so I'm okay. So yeah, we can scratch all that. We can use the left coordinate li because it's been filled here. Okay, so it's really just the left coordinate, right, of the button plus the size of the button, or the width of the button, which is the same as the height. So it's the size. Okay, so that gives us our right coordinate. But make sure that's a common mistake when we're copying and pasting, to not change that variable to right. Right. So, and then so it's the left coordinate plus the size. So let's copy that, and then the top will be just all initial yi. So the top I will equal to yi, and then the bottom will be just like we did with the right, the bottom, and it will be the yi plus the size. Okay, so those are all populated now, and they have the correct coordinates in them. All right. So now we can draw our buttons, except we can do it with a for loop and draw all of our buttons at the same time. We'll just keep them all the same color. We'll leave the rectangle there so we can see what we're doing, and we'll start a for loop. I is less than num buttons, I plus plus. And we'll just put that rectangle in there. And then what is this going to be? The x is going to be our left, right? So li. And then what is our y coordinate? Well, it's going to be top I. And then our size will just be the size. It'll be sc. So we don't need to use an array for those ones. All right. So let's run that. Oh, okay. Well, I guess we changed some of these variables. Let's just comment that out for now, because I'm going to change all that anyways. So, oops. Okay, so see, now it drew our 5 buttons. And again, you can just change the number of buttons, and it will automatically draw you that many buttons. Okay, so it's a really handy and easy way to do a multiplicity of things. Okay, so now what we have to do is we have to, if we want them to play different samples each, we have to iterate through this kind of exercise. We have to compare it, the mouse location, to the 4 sides of the square of the button, and that's why we need left, top, right, and bottom. An easier, well, in my opinion anyways, a sort of helper is to just write a function that's going to do the detection for us, so we don't have to type all that every time we want to do detection. So let's create a function, and we're going to create a function this time that returns something. Okay, so all this void business that we've been using up to now means that it's a function or a method that doesn't give you any result back, doesn't return you anything. Okay, but you can also write functions that return something. So another way of saying that is the function itself becomes that variable. So when I say something like, in this case, I'm making a Boolean because I want to know if it's touching the button or it's not touching the button. So is it true, it's touching the button? If it's not true, it's touching the button. So we'll just call this a Boolean. So it's going to return a Boolean variable, and we'll just call be on button on. Okay, and we'll get back to the variables because we do have to give it some variables. But now to give you the structure of this is you have to return a Boolean. That's why you see those red lines as complaining. So we're going to create a Boolean within this function. We'll call it on, and initially we just give it the initial value of false. Okay, and then we just, at the end of our function here, we're going to return on, which is a Boolean. Okay, so now it stopped complaining. So basically now when we call this function, and the way you call the function would just be say be on and the brackets like that with whatever arguments inside, that entity right there will become a Boolean itself. So you can say, use it in an if statement, for example, of what you're going to do, if be on function. Okay, and it'll be true or false. Okay, and you'll see how we use that later on. So we're going to create a Boolean be on. Its initial state is going to be false. All right, and we're going to have these arguments because what we want to do is detect if the mouse is in touch with one of the buttons. So we're going to need 4 integers, and it's going to be just the left, right, top, bottom again. So int left, int right, int top, int bottom. Okay, left, right, top, bottom. And we'll basically recreate this kind of situation. So we'll say if, except now we have these nice tidy variables. So we say if mouse x is greater than or equal to the left, and mouse x is less than or equal to the bottom, right, sorry, and mouse y is greater than or equal to the top, and mouse y is less than or equal to the bottom. Okay, so that's our condition there. And then what are we going to do then if that happens? Well, this is the point where we just return something. We're going to say on equals true. Right, and then we return on. Okay, so basically it's going to return false if you're not touching a button. If you're touching a button with these coordinates, then it'll return on. So that's a nice tidy little function that we can just declare in a more simple way instead of using all this verbiage here. Okay, and so what we'll do is we'll again use a for loop in mouse pressed to iterate through all the buttons. So we'll say for int I equals 0, I is less than numbut I plus plus. Oops, I'll make that a curly bracket. Okay, get rid of those here. And we'll keep the if statement because we're going to alter it, but make sure we shore up that curly bracket there. Okay, for a number of buttons. So through all the buttons. Now we have to use this function. So we're going to use that function button on, which will do the comparison for us. So be on, and then it has all those arguments though. We have to put left, right, top, bottom. Okay, and then we just grab those from those arrays then. So we'll say left will be L, I for that particular button. So it's going to go through all the buttons and then compare it to each button where our mouse position is. Left, right, I, top, I, and bottom, I. Okay, it'll compare it to each of those things, and then it'll send this message. Now, then you can change the sample number it sends by making that I instead of 0. All right, so it's going to play I, sample I, depending on which button it's touching. All right, so let's save that, and we'll run it, and then see how that works. I think I only have 5 samples anyways. They'll just repeat. I'll go back to the 0 sample. Yeah. Okay, great. So that works really nicely. And you see, just from a little code like that, you can have as many buttons as you want. And if you populate your super collider with a load of samples, you can have a bunch of different samples as well. Okay, so I'll end this video here, and then in the next video, I'll pick this up, and we'll do some enhancements to our sampler GUI. So good luck with that.